We'll get this thing configured here one way or the other. I'm gonna have to unplug something. Put that in there somehow. I don't know what I can unplug and what I can't unplug. I'll try that and see what happens. It's still not gonna work, is it?
Yeah, the iPhone charger is really.
Is that okay? Is it gonna stay up there or is it stretched
Yeah.
too tight?
See that? There we go. That should be. That should
Is that gonna be okay?
Yeah.
All right, finally, I think we're ready to go. Sorry about that. Okay, here we go. Who had a question about one of these problems? Sorry, not to.
3A.
3A. All right, we are graphing a piecewise function. So here we go. Okay, so I'll just look at the first piece. What shape is that? That's a line. It's a line that has a y-intercept of 2 and a slope of 1. So if I were going to graph this thing, it would look like this. Now the problem is, that's the line right there. The problem is I don't want the whole line. I only want the part of the line where x is less than or equal to 1. So I only want, here's where x is 1. This is where x equals 1 right there. And I only want the part where the x's are less than that. So I don't even want this part of the line, so I'm just going to erase it. Because I only want the part of the line that has x values that are less than or equal to 1. Now what's this? The second equation. What is it?
Go down.
It's another line whose y-intercept is 0 and whose slope is -2. So down 2. So that line would look like this. Supposed to be a straight line. Would look like this. But I don't want the whole line. I only want the part of the line from, again, where x is 1, so that would be right here, and then greater than 1. So I don't even want this part of the line. I only want the part of the line that has x's that are bigger than 1. This is where x is 1, this is where x is bigger than 1. And that's it. Was I supposed to answer any questions about it? Nope, just graph it. That's it. Let's answer a couple questions about it. What would be its domain? All real numbers. What would be its range?
Less than 2.
Less than or equal to 3? Yeah. All right, Elaine, did that take care of it for you? All right, who else had a question about one of these problems? Jessica?
Never mind, it was 3B, so it's the same.
Well, it's a different equation, so we'll just go ahead and do it. All right, so First equation is y equals the absolute value of x. What shape is that? That's a V, and it's just the standard old V, so I'm just gonna go ahead and draw it. There it is. But I don't want the whole V. I only want the part of the V that has x is less than -2. So that would be just this part of the V. So I'm gonna get rid of all of this. I don't want all this. I want only the part of the V that has x coordinates less than -2. What's the second part of the equation look like? Y equals x plus 1? But there's only one point on this one. I'm not gonna mess around with the whole line because this says the only thing I can let x be is -2. And what happens if I let x be -2? I get -1. So that is just a single point. This is a line, but you would not be looking at any part of the line except one single point where x is -2. What's the bottom one?
It's like a parabola.
It's your parabola. And what part of that parabola am I interested in?
X is greater than -2.
I want the part of the parabola, I should have plotted some points here. So be careful on that. There we go. So I want all the parabola where x is greater than -2. So here's where it equals -2. Here's where it would be less than -2. Everything to the right of that point is what I want. So that's a picture of that one. This does go on forever and ever, so. That's what that one looks like. What's its domain? Oh, real numbers. What's its range? This is a little tricky. What's the range here? Greater than or equal to 0. Very good, Delaney. Greater than or equal to 0 or equal to -1. We can't say greater than -1. So do you see that? Because this space in here is empty. So we say everything bigger than 0 or equal to 0 or equal to that. Good. Good, good, good. Okay, who else? Now we've done both of those. So who else has one? Logan?
Can you do 2D?
2D. And the question is, find the vertical asymptotes, horizontal asymptotes, and holes. Okay. Okay, so Logan, what was your thought to get started? Well, I've already done it for you. What did I do? Even as I copied down the problem, what did I do?
Well, I didn't understand where
Okay, stop. What did I do when I copied down the problem?
you factored it out.
Yes, so that's step one. Let's get it factored. Okay? Now, does anything cancel?
No. Oh, the X's.
Don't they cancel? And the fact that they cancel tells me that what am I going to have in my problem? A hole. You only have holes when you cancel, right? And I did, so I have a hole. Now where will that hole be? Since I canceled out a plane X, the hole will be at
At the X. Or 0.
0. That's going to be at 0. If this had canceled, it would be at -4, right?
Got it.
There's no number attached to this, so it's just plain 0. Now, what do I do with the 0?
You plug it in.
Right here, and it tells me that the y coordinate of my hole would be 5/4. Now, my horizontal asymptote and vertical asymptote, I can just look at what I have left. Is there anything that makes the denominator 0? -4. So I have an asymptote, a vertical asymptote at x equals -4. X can't be -4. Now my horizontal asymptote's a little tricky because there's no x up here to balance out this one. So what does that tell me? If there's no x up there, then where's my horizontal asymptote going to be?
0.
At y equals 0. 0x over 1x. 0 over 1, that's going to be at 0.
Gotcha.
All right, who else? Good questions. Who else has something on the sheet that we need to take a second look at? Madeline?
2C.
Which one?
2C.
2C is exactly the same kind of problem that we just did. So how are we going to start it? And we notice what? Nothing cancels, which means what? No holes. No holes to worry about. Okay, where are my vertical asymptotes? I got 2 of them. X equals 3, x equals negative 3. Okay. How about my horizontal asymptote?
Y is 1.
Y equals 1. So you just answered that question. Why did you ask me about it?
I was just confused because they didn't cancel out. The holes. I didn't really know what the holes.
Okay, if nothing cancels, then there aren't any holes. I mean, okay. No need to be confused. There just aren't any. Jessica?
For the vocab on number 7, for removable and non-removable, are we just allowed to say for removable it has a hole and for non-removable it doesn't?
No, for non-removal, it's a vertical asymptote. Yes. Okay.
So it's odd where the function is symmetrical with the origin.
Anything else from this paper?
Can we do 5E?
5E. This is a composition. And then we also need to answer the domain and range of it after we get it written out here. Let's see, f of x is 2 over x, and g is 2x squared. Okay, g of f of x means we're going to plug f into g. So we're going to plug f into g. So we're going to find g of 2 over x, right? Because it says g of f of x, that's f of x. So that's going to be 2 times 2 over x squared. The g function says square it and times it by 2. So that would be 8 over x squared.
Two only multiplied by okay, no, it's not that.
Now, it asks me for the domain and the range. Now, the domain is probably easy. What can you tell me about the domain? X can't be 0. X can be anything I want, but it can't be 0. The range on this one's a little bit tougher. You really need to think about it for a minute. 8 over x squared. First of all, does it make sense to you that this will always be positive? Which means that no matter what I plug in for x, the answer will always be positive, which means its range will be y is greater than 0. Yeah. Now, if you were graphing this on your calculator, or if you were plotting points by hand, you would see that. But if you don't have a calculator available to you, you just got to kind of think about it for a minute. What happens when I plug in numbers? Well, you can get anything as long as it's positive. So your range is greater than 0.
Perfect.
Okay. All right, anything else from this sheet? Jessica?
This is just a question about the test. Do we have a non-calculator and calculator section, or?
Probably, I haven't written it yet, quite honestly, so I don't know, but probably that would be my guess. In fact, I'm not even sure we need a calculator at all on this. It may be totally no calculator.
So we won't do the, like the scatter plot?
Oh wait, that's in this chapter, isn't it? Yeah, regression, yeah, we'll definitely need a calculator for that. Yeah. I'll get back with you on that after I get it written.
Thank you.
Okay, all right, let's look at this sheet that we started on Friday Remember I had you fold the paper in half because the answers were right there? Okay, this is the heart and smile face paper, and I think, were we down ready for 4?
We're on 6.
Oh, we're on 6. You're amazing people, good for us.
We're on 4. We can get some.
Yeah, we're on 5.
We're on 5? Okay. Okay, so we're on 5, which we kind of have already talked about today on a couple of other problems. To list all the asymptotes and holes, what's the first step?
Factor.
Okay, so let's see. I can take a 2 out. Of the top and the bottom. Okay, so what cancels? Looks like some stuff cancels. The 2 cancels, but that doesn't matter, that's just a number. What else cancels? So really, we are left with 2x plus 1 over x. Right? So, let's see. Where will my hole be? Where x is 4. The 2 is just a constant. It doesn't have anything to do with anything. How do I get the y coordinate? Plug it in, and what am I going to get when I plug it in? 9/4. Okay, so there's my hole. Where's my vertical asymptote? Where?
0.
Oh. Yeah, should I not be?
Should be.
Oh, okay. Do I look unusually frazzled or something? I wonder. Okay, anyway, come on now, what can x not be? 0. So you got a vertical asymptote at 0. And where's your horizontal asymptote?
2 over 1.
Y equals 2. Yep. Y equals 2. That was easy enough. Okay, implicit functions for 9y squared equals x. What does that mean, implicit functions? What do I need to do? I need to get y by itself. So y squared equals 1/9 x, or x over 9 if you prefer. So what does y equal? Plus or minus root x over 3? And those are your implicit functions.
So implicit would just make it equal to what? Or,
What?
never mind.
Okay. All right, next it says, draw a basic sketch of the 12 basic functions, talk about their domain and their boundedness. Okay, that reminds me of the kids who had to make up a quiz. Their quiz question, one of their quiz questions, was this. There are 6 basic functions that are continuous and increasing. Name or write the equation for 4 of them. so you really have to know what your basic functions look like, and you have to know what increasing and continuous mean. All right, so here we go. Can you think of a basic function that is increasing and continuous? Okay, somebody said the identity. So this right here, right? Somebody else said the parabola. This one bothers me. What bothers me about that? Yeah, this bothers me because this is not increasing, so that isn't one. Somebody else said the cubic function. Does that one seem to work okay?
Yeah.
Okay, so we got two.
Square root function.
The square root function. The square root function, remember, looks like this. Is that continuous and increasing? Yeah. Natural log function, somebody said ln x. That would look like this. Is that continuous and increasing? Yeah. So we've got 4, but there's 2 more. Let's see if we can find the other 2. The exponential function. The exponential function looks like this. The logistic function looks like this. Is that one increasing and continuous?
Yeah.
There they are. There are the 6. Very, very good. So this one is not, because it's not increasing. It's definitely continuous, but it's not increasing. Okay, what are the other 6 functions then? One was the parabola. I got it. Okay, what are the other? You got the sine and the cosine. And the thing about the sine and the cosine is they are continuous, but they are increasing and decreasing over and over and over again, right? Which one is this? That's the sine. And you got your cosine. Okay, so let's see. Right, that's 3 more. Okay, we need 3 more.
Absolute value.
Absolute value. Okay. The greatest integer function. They use different notation, doesn't matter. This is your greatest integer function, just like this. Okay. And isn't there, do I have them all up here?
That's 11.
That's 11, okay, one's missing. The reciprocal function. And it looks like this. You need to be able to do that, okay? You need to be able to create those pictures. All right, what's next on the sheet? Okay, number 8 is sketch this thing. What shape is it going to be?
Absolute, so
It's going to be a V, right?
But it's gonna be going down.
And it's going to be an upside down V.
it's gonna be up there.
And where is its like vertex going to be? Its point there.
Up there. Or 3.
Or
Negative 1.
left 1 and up 3.
Yeah.
There it is. How do we know it's upside down?
Negative.
Negative. Left 1, up 3. Okay, number 9 is a sketch. I'm gonna have somebody else come up and do that. I've already done 2 of those today. 10, regression. We gotta know how to do regression on our calculators. And then number 11, relative or absolute max or min. So at -1, at x equals -1, how would you classify that point? But you can't just say minimum, you have to say, is it an absolute minimum or is it a relative minimum? That's an absolute minimum at -1. What about at 1? Absolute maximum, and what about at 3? Relative minimum. Okay? All right, can I have a volunteer to come up and do number 9 on the board? Sketch it however you want, whatever strategy you want to use to get it sketched. Volunteer? Bob, you two, what you did together? Maybe what you helped. And then, okay? The rest of you, let's try that at your seats. Probably gonna have one of those on your test.
And then this would just be
It's gonna have to be Thursday. And Wednesday, we're gonna start the next chapter, though we don't have a day to waste.
Are classes really short?
They're 30 minutes. Or 25 minutes, something like that. They're pretty short.
Can you help me with, I don't understand that. Absolute minimum, absolute maximum. And I understand that.
Absolute means the single lowest point. Where x is -1, that's the lowest point on the x.
Okay, that makes sense. Okay, thank you. I get it. I thought
Okay, we should all be sketching this. Okay, step aside for a second. We have, so they can all see it, we have an issue here. I don't know what this is supposed to look like, but this is bad news. Why? Can anybody tell me why this is bad news? It doesn't pass the vertical line test. So, I don't know what happened, but one of them says x has to be less than 2, and one says x has to be greater than 2, and you've got to both go on x greater than 2. Do you see what I'm saying? Yeah. Okay, now at least it's a function. I still don't know if it's right or not, but at least it's a function now. Okay, now, what do the rest of you think about this? What?
Doesn't go down, though.
When you did did this, you guys, you were right. I don't know why you changed your mind. Because the line y equals negative 2x has a negative slope. So it's gotta be going this way, right? And you can just plot a few points if you want. Yeah. Okay. Otherwise, it looks okay. All right, so what's your domain?
Just get it. Wait, no.
Oh, numbers for sure, right here, it tells you, that's everything. What's your range? This is the point down here, -2. So what's your range? Just greater than -2. Yep, y is greater than -2. Good, very, very good. Now, a couple more questions for the makeup quiz. Let's take a look at this. It says if the range of this weird function is this, what would the range of this one be? What do you think? Knowing what you know. Exactly. It would be what? This has to be greater than 3. Why? What changes going from this to this? What happened? Everything got lifted up 3 units. So if the original y's were bigger than 0, if everything gets lifted up 3 units, won't the new y's be bigger than 3? Similarly, if this had been that, what would that be? Bigger than -4? Because then you would have taken the whole picture and dropped it down 4. Okay. Then this question said, this was the given. This is just the given. And it said, would you classify that function as even, odd, or neither, and explain? Okay, so we need to stop and think about what does even mean by when the function's even, it means it has what? Symmetry over the y-axis. So I just want you to think about that for a second. Symmetry over the y-axis means that if the point 4, 1 is on the curve, then so is what point? -4, 1? This would mean, this relationship would mean you have an even function because that's symmetry across the y-axis. So if one of the points is 2, -3, then what would the other point have to be? If we had symmetry across the y-axis, the other point, -2, -3. Is that the point that I have? No, so it can't be even. All right, what does odd mean? Symmetric about the origin, which means if the point, let's say 2, 1 is on the curve, then what point would be on the curve if it had symmetry across the origin? -2, -1, right? Okay, so we've got the point 2, -3. What point, if we were going to have symmetry across the origin, what point would we have to have that matches up with 2, -3? -2, 3. Is that what we have?
Yes.
Oh, okay. So we've got symmetry across the origin, so that means the function is odd. Okay, good. Good. Well, let's take a look at our packet of stuff, because we even have more in here. There's a sheet called, just a minute, Random Practice, 1.1 to 1.4, Random Practice. Could you do number 1 without plotting points and without your calculator? What would it look like? What shape? What shape? A V. And where would it be vertex from? right 3 and up 2? Everybody okay with that? Stark, do we remember that when it's x minus 3 inside the absolute value, that moves us 3 units to the right? Okay. All right, number 2, is this thing even, odd, or neither, or why? Well, visualize the graph. What's it look like? It's symmetric about the y-axis, which means it is even. And not be a function. It can't be, but a circle is even and odd, but it's not a function. Okay, number 3. Okay, how do we do this? Those are little open circles. My pencil wasn't very sharp. So we're finding C of H of S of 4.
Plug in 4 to S.
So first we plug 4 into S. Now let's not be confused by this, although it's easy to be confused. This means that no matter what I plug in, what am I going to get out of this function? No matter what you plug in, you're always going to get out a 2. So I'm going to plug in 4, I'm going to get 2. This is a constant function. No matter what you put in, it doesn't matter, the answer is 2. So I plugged in 4, which is what I'm supposed to plug in, I got 2. All right, now what do I do with the 2? Put it into H, and I will get 36. And then what do I do with the 36? Plug it into C, and I will get 73. So the answer to the problem is 73. We've done a ton of these piecewise today. Let's skip number 4 and go to 5. What's the domain? We haven't talked too much about domain today. What's the domain for A? What is it? Greater than or equal to negative 5/3? Because whatever is under the radical has to be bigger than or equal to 0. So that would say x is bigger than or equal to negative 5/3. Perfect. B.
All reals.
All reals. Good. C. X is not equal to 5. Good. For number 3 above, what is the domain of C plus H? So you can add C and H together. What would be its domain? All reals. Because C and H, if you add them together, look at them individually or add them together, they have no radical and no denominator. So their domain is all real numbers. What's the range of the identity function? All real numbers. Think about it. Think about the identity function. What's the range of the absolute value function? Greater than or equal to 0. Remember, it's the B that starts here and goes up. It's not everything. Sketch the cubing function. Can you do that? Right? You know what that looks like, right? You have to. Well, we made quick work of that. For tomorrow, your homework is in the textbook. And then your homework tomorrow night, actually, no, tomorrow night will be a little bit different. So we have 2 more review assignments. One is in the book, and one is in your packet. There's another review sheet called Review Sheet 2. I think it has a number 2 on it. And I'm only telling you that that's going to be your assignment before the test. That has to be done. We're a little bit whopper-jawed because we can't take the test on Wednesday. So tonight is the book work. Tonight's the book work, but if you have some extra time, it's kind of a short assignment. You might want to go ahead and get started on this so we can ask questions tomorrow. Tomorrow's our last review day. Wednesday we will start the next part of the chapter, and then Thursday we'll take our test. Okay? Everybody clear Clear on this?
Yep.
All right.